On August 1st, 2025, I stood at the Hayden Planetarium and announced a revelation that would send shockwaves through the scientific community and beyond. Neptune, the eighth planet from the Sun, as we know it, might not exist at all. The air was thick with anticipation, and every eye in the auditorium was fixed on the podium, waiting for the words that would challenge everything we thought we knew about our solar system. Instead of a single massive planet, new evidence suggested that Neptune is nothing more than a cosmic illusion, a trick of gravity and light that has fooled astronomers for nearly 2 centuries. What we believed to be a distant blue giant was, in fact, a mirage created by the complex dance of countless smaller objects, their combined mass and movement mimicking the presence of a planet. The reaction was instant disbelief, a global gasp echoing across newsrooms, living rooms, and social media feeds. The world was captivated, stunned by the possibility that one of our solar system's most iconic members might never have existed as we imagined. This wasn't a simple reclassification like Pluto, it was the loss of a planet, a symbol of the solar system's edge, a celestial body that had inspired generations of astronomers, dreamers, and storytellers. For scientists, it was a seismic shock, a moment that forced us to question the very foundations of planetary detection, orbital mechanics, and the methods we use to map the cosmos. Decades of research and textbooks were suddenly thrown into doubt. The Ethelred Space Telescope's data pointed to a stranger reality. Neptune's signature was not the fingerprint of a single planet, but the combined effect of a massive swarm of smaller, darker objects, all orbiting together in a complex coordinated ballet. The evidence was undeniable, and it demanded a radical rethinking of our understanding. Standing at that podium, I felt the weight of challenging 179 years of science, knowing that my words would ripple through classrooms, observatories, and dinner tables around the world. Neptune's discovery was once celebrated as a triumph of Newtonian physics, a planet found by math, not just by sight. It was a testament to human ingenuity, a moment when calculation and observation came together to reveal a new world. Now, we were rewriting that chapter, suggesting that the celebrated discovery was in fact based on a misinterpretation, a cosmic coincidence that had led us astray for generations. But science thrives on self-correction, on the willingness to abandon even our most cherished ideas when new evidence demands it. This is the heart of discovery, the courage to admit when we are wrong, and the determination to seek the truth, no matter where it leads. The cosmos had handed us a new mystery, a puzzle that would challenge our intellect and imagination. Our duty, as scientists and explorers, was to follow it, no matter how unsettling or humbling the journey might be. The world watched in awe and confusion, as a familiar landmark in our celestial map was declared a mirage, a ghostly echo of what we thought we understood. Teachers scrambled for answers, the internet erupted in confusion, debate, and wild speculation. Every corner of society was touched by the news, as people struggled to make sense of this cosmic revelation. This was not just a scientific update, it was an existential crisis for our understanding of the solar system, a moment that forced us all to confront the limits of our knowledge and the mysteries that still await us in the darkness beyond. And so, the journey to unravel Neptune's true nature began, a quest that would push the boundaries of science, imagination, and human curiosity further than ever before. To truly grasp the shockwaves sent through the scientific community by this new hypothesis, we must journey back and revisit Neptune's remarkable and storied history, a tale that has shaped our understanding of the cosmos. Neptune's story began with a cosmic mystery. Astronomers noticed that Uranus's orbit didn't quite match what Newton's laws predicted, suggesting the presence of an unseen force tugging at the planet. In the mid-1800s, mathematicians Urbain Le Verrier and John Couch Adams, working independently, used complex calculations to predict where this mysterious invisible planet should be found. Then, in 1846, Johann Galle, guided by their predictions, pointed his telescope at the night sky and discovered Neptune almost exactly where the math had indicated. A stunning confirmation. This was a triumph for science and mathematics, a planet discovered not by chance but by the power of human reasoning, validating Newtonian physics, and the predictive power of mathematics. Neptune quickly became a symbol of our ability to comprehend the universe through logic and calculation alone, inspiring generations of scientists and dreamers alike. For over a century and a half, this story has been a cornerstone of astronomy education, taught in classrooms and lecture halls around the world as a shining example of scientific discovery. When Voyager 2 flew past Neptune in 1989, it revealed a dynamic, stormy world with fierce winds and mysterious dark spots, reinforcing Neptune's status as a true ice giant and deepening our fascination. Every textbook, every classroom model, every planetarium show for decades has featured Neptune as the eighth planet, a fixture in our solar system's story. Its existence has been a bedrock fact, a gravitational anchor in our map of the cosmos, shaping how we see our place in the universe. But now, with new evidence and bold ideas emerging, we are forced to re-examine this legacy and question what we thought we knew. To question Neptune is to question the very narrative of scientific progress itself, challenging us to rethink the foundations of our cosmic story. What does it really mean to call Neptune a cosmic illusion? The phrase itself sounds almost mystical, but it's rooted in the very real mysteries of astronomy and the limits of our perception. The gravitational pull and faint light we detect from Neptune are undeniably real, measurable, consistent, and observed by generations of astronomers. But what if our interpretation of these signals is fundamentally flawed? For centuries, scientists and stargazers alike have assumed these signals must come from a single, massive planet orbiting far from the Sun, a distant blue world at the edge of our solar system. Now, a bold new hypothesis, built on unprecedented data and advanced simulations, suggests something astonishing. We may actually be observing a vast gravitationally bound swarm of thousands, perhaps even millions of dark planetesimal-sized objects, all moving together in a complex cosmic dance. This so-called Ethelred swarm collectively mimics the mass, gravitational influence, and even the faint light signature of a single planet, fooling our instruments and our minds alike. The mathematics behind Neptune's discovery were correct about the total mass present in that region of space, but completely mistaken about its form, mistaking a multitude for a monolith. Our telescopes, limited by distance and technology, blurred this swarm into a single bluish disk. The blue color, long thought to be from a planetary atmosphere, may actually arise from exotic ices coating these countless small bodies. Even Neptune's famous storms, those swirling, ever-changing patterns, could be transient phenomena, the result of collisions or temporary bunching within the swarm rather than weather on a true planet. In this light, Neptune is revealed as a cosmic composite, a ghostly average of countless smaller bodies masquerading as a single world. This revelation doesn't diminish the achievement of Neptune's discovery. Instead, it adds a new layer of wonder and complexity to our understanding of the cosmos. The universe, it seems, is far more creative and surprising than we ever imagined, constantly challenging our assumptions and expanding our sense of what's possible. For nearly 2 centuries, we've been watching a planetary doppelganger, a beautiful illusion crafted by the universe itself, waiting for us to see through the cosmic veil. Extraordinary claims require extraordinary evidence, and the Ethelred Space Telescope delivered. Designed to image exoplanets, its unprecedented resolution revealed chaos where Neptune should be. Instead of a sharp planetary disk, the images were noisy, mottled, and shimmered, evidence of countless unresolved sources. The telescope's coronagraph exposed a web of faint moving lights, the individual members of the swarm. Spectrographic data showed these objects shared a composition rich in frozen volatiles, but lacked the deep atmosphere of a gas giant. Gravitational lensing analysis revealed a lumpy field, not a single smooth dent. All the data converged. At 30 astronomical units, there is not a planet but a crowd. Neptune, as we knew it, had vanished into a swarm. The swarm hypothesis elegantly solves old mysteries. Triton, Neptune's retrograde moon, was likely captured by passing through a chaotic, lumpy gravity field, far more plausible with a swarm than a single planet. The swarm's constant gravitational jostling and collisions generate tidal friction, explaining Neptune's excess heat. This distributed energy source accounts for the infrared radiation we detect. The swarm itself is a fossil of planet formation, a massive collection of planetesimals that never coalesced. It challenges the classical model, showing that in the outer solar system, accretion can stall. The Ethelred swarm is a living relic from the dawn of the solar system. It's a snapshot of a process we've only simulated until now. Confirming the Neptune swarm hypothesis would upend planetary science. Models of solar system formation would need rewriting to include stable, gravitationally bound swarms. Some exoplanets we've detected might also be swarms, not single worlds. Future missions to Neptune would face the challenge of navigating a dense, chaotic field of objects, not a solitary planet. Textbooks and planetarium shows would become obsolete overnight. The 8-planet model would shrink to 7 in a swarm. Educators would have to explain this strange new reality to the public. The mnemonic, "My very educated mother just served us noodles," would end at us. This discovery is a humbling lesson. Our knowledge is limited by our tools. It's a paradigm shift that will make our science more robust. The cosmic illusion hypothesis has ignited fierce debate. The scientific community is split. Swarm proponents find the evidence compelling, while planetary traditionalists demand more proof. Traditionalists cite decades of consistent observations and question whether the new data could be an error. Swarm proponents argue the AST's findings elegantly resolve long-standing mysteries. The debate rages in journals, conferences, and on social media. The public, too, is divided. Some mourn the loss of Neptune, others are captivated by the strangeness of the new idea. Conspiracy theories abound, but so does wonder. The debate reflects our enduring fascination with the cosmos. Whatever the outcome, this episode is a lesson in scientific humility. Science is not a static collection of facts, but a dynamic process of inquiry. Our models are only as good as our tools and evidence. The Neptune story, once a monument to our intellect, may become a cautionary tale about assumptions. The universe is not obliged to fit our expectations. The possibility we misread Neptune is not a failure, but a celebration of science's self-correcting nature. Every leap forward builds on what came before, even as it reshapes our understanding. We should embrace uncertainty and debate. It's the engine of discovery. These moments of confusion are when science is most exciting and most human. We are not masters of the universe, but its students. The coastline of knowledge shifts with every new tide of data. Tomorrow's discoveries may change everything we think we know today. As the Neptune debate continues, we're forced to ask, what else have we gotten wrong? If Neptune can surprise us, what other cosmic illusions await discovery? The universe is stranger than we can imagine. Some exoplanets or galactic phenomena may be swarms or collectives, not single objects. The Neptune hypothesis challenges astronomers to re-examine old data and design new tools. The quest to understand the cosmos is humanity's grandest adventure, full of plot twists. The solar system still holds secrets, hiding in plain sight. As we build better tools, we're not just filling in details, we're redrawing the map. The Neptune debate is a signpost, pointing to a future of profound discovery.